Sharma, Assistant Professor, Ajay Kumar Garg Engineering College. Today I am going to start with the second lecture of the subject, that is data communication networks. Code is KEC 063. In this lecture I am going to discuss about OSI model and TCP IP protocol suite. Now, what is TCP IP? TCP IP is transmission control protocol. These are the contents of this lecture, that is layered task. I am going to introduce that what is layered task, how the information will be transmitted in form of layers, then OSI model, then TCP IP protocol suite. So, I will begin with what is layered task. So, whatever work we are doing in our day to day life, whether it is related to professional or some personal work, these all works are there in the form of layers only. Like you can see, this is a simple example that I have taken from a book, that is Frozen. Sender and receiver are involved in the communication. This is the basic component of communication. Now, I am going to explain that how the information will be transmitted in the form of layers. Like you can see that this is an example of transmitting a parcel or a letter from sender to the receiver. A letter is written, put in an envelope and dropped in a mailbox. This is the first step. Second, at the second layer, the letter is carried from the mailbox to a post office. Second, third is letter is delivered to a carrier by the post office. What is the carrier? Carrier may be through the mail van, it will going to transmit it, or through aeroplane or any any device or any vehicle, it will going to transmit it. So, that is an example of carrier. The parcel is carried from the source to the destination. Now, coming towards the receiver side, as we move from here, this is the downward, this is the upward direction. The letter is delivered from the carrier to the post office. Letter is carried from the post office to the mailbox, and then it is picked up, removed the envelope, and it will be read by the receiver. So, as you can see that transmitting or transferring any parcel, any courier to from transmitter to receiver, the data will be transmitted in the form of layers. Like this is the higher layer, this is the middle layer, and this is the lower layer. So, 3 different layers are involved. So, any data, any kind of program or any kind of work that you are doing in your office also. So, there are different levels are there for doing any kind of work. So, that is the basic idea of the layered task. Now, next is the OSI model. What is OSI model? It is established in 1947. The International Standard Organization, that is ISO, is a multinational body dedicated to worldwide agreement on the international standards. So, ISO is basically, you all know about ISO certified means organization that has the capability or that will going to provide an agreement on the international standards. So, an ISO standard that covers all the aspects of network communication is known as OSI. So, a model that has been designed or that has been agreed by the ISO, that is known as OSI model. In this OSI model, all the information related to the networks are involved. So, that is known as it is also known as ISO OSI model. ISO means International Standard Organization, OSI is Open System Interconnection. So, it was first introduced in the late 1970s. Now, this is the layered architecture, this is known as OSI model. There are 2 devices are involved in the communication, device A and device B, and you can see that the intermediate node, or you can say the nodes which are involved in which are there in between the connection between the transmitter and receiver is known as intermediate node. It can be a router, it can be a gateway, it can be a hub. These are the connection setting up devices. Now, there are 7 different layers of an OSI model. First layer is the physical layer, second is data link, third layer is the network layer, fourth is transport, session layer, presentation and application. So, as you can see that there are 7 layers, same present at the device A and same present at the receiver side or the device B, which is the receiver. So, this is transmitter, this is receiver. So, you can see that whatever information will be generated or which is to be transmitted from device A, it has to be transmitted from this application, presentation, session, transport, network, data link and physical layer. It has to be transmitted through this physical communication and then it has to be delivered to this part, to this device A through this physical data link, network, transport, session, presentation and application. In between the two layers, wherever you can see there is a 2-1 interface, 3-2 interface, 4-3 interface, means there is an interface or the connection has to be set up between any two layers. This is you can see that a peer to peer protocol, means directly from transport layer, 4th layer to 4th layer, the communication will take place in session layer, presentation and application. So, these 4 layers direct communication of the protocol setup will be there, but in this case there are some intermediate physical data link network operations are there, which are associated with these nodes. So, we will see each detail of each of the layer one by one with a detailed diagram. These are the layers in the OSI model. First one is the physical layer. As you can see that physical layer is the first layer. It will receive the data from the data link layer. This is at the device A, or you can say this is at the transmitter side, this is at the device B. So, this is the physical layer. The data is in the form of 1 and zeros, because it has to be converted into digital form. Then a header is being inserted here and the same header has to be used over here. So, that the proper synchronization between the transmitter and receiver will take place and they will going to transmit the receive the data at the same point of time. There will be no delay, but practically it is not possible. Theoretically it is there, practically there will be a kind of delay is there, and then it is transmitted through this transmission medium. And I have said that there are two types of transmission mediums are there. First one is the wired transmission medium, another is the wireless transmission medium. So, this is the layered OSI layers in the OSI model. First is the physical layer, second layer is the another layer is the transport layer. This is the transport layer which will going to receive the data from the session layer. These are the data. You can see that at the transport layer the data is broken into, or it is divided into different segments, and each segment has their own header and that header will be same H4, H4 and H4. Header and 4 means it is the fourth layer part. So, that is the header. At the receiver side also, from the network layer the data will going to be received and it will be divided into different segments. So, this is the part of transport layer. Now, next is the session layer. Session layer means it will going to receive the data from the presentation layer, and then at the session layer you can see that the data is not divided into different segments, but what they will going to do in the OSI model, it will be generated into different slots and the synchronization is being set up between the different segments, and over the top there will be a header which is of the fifth layer and a header will be there. Same header has to be used at the receiver side to maintain the synchronization. So, this is about the session layer. Next is the data link layer, that is the second layer. In case of this data link layer, the data will be received from the network layer. You can see that this is the trail bits, this is the header, because it is related to the second layer and this is the header. So, it is denoted by H2 and this is denoted by T2. Same header and trail bits has to be used at the receiver side. So, this is H2 and this is T2. Now, these whenever we are going to insert in case of network only, whenever we are going to add header and trail bits to the data, header are always been added at the initially and trail bits will be added at the end side, it will make up a frame. So, this is the frame that has been formed at the data link layer. Next is the network layer. In case of network layer, this is divided into packet. This is known as packet, and this the data will be received from the transport layer, it will be delivered to the data link layer, and the headers are there like H3 because it is associated with the third layer. So, the header will be added in front of in the beginning of the data. Next is the presentation layer. This is the presentation layer. In case of this presentation layer, this header will be added from the application layer to the session layer. Then from the presentation layer, the data will be taken from the session towards the application layer. In case of this presentation layer, no segment, no frame or packets will be formed, it is just going to be transferred from as it is with the addition of the header. So, till now you have seen that different layers are there, at every point of time a header will be added, and the addition of header and data of the previous layer will act as a data for the next layer, and at that particular next layer the another header will be added. So, I am going to provide you the diagram of that particular situation. Last one is the application layer. In case of application layer, the data will be generated from the user human or program. This is the device A part, which will going to generate the original data. It will going to transmit, it can be any kind of application like X.400 FTAM, X.500, any application will be used. Like if I want to print a document from the, let us take an example of device A, that is a computer, device B will be a printer, and a computer wants to take a printout from a printer. Then it has to follow these 7 layers at the transmitter side and again the 7 layers at the receiver side. So, whatever application associated with the printing of that particular document will be used at the application layer. Then it will going to act as a data and the header will be added, because since it is the 7th layer. So, the header 7 will be used over here. So, this is an 7th layer. Now, this till now we have discussed about the OSI model, ISO OSI model, where 7 layers are involved: physical layer, data link layer, network layer, transport, session, presentation and application. Next, we will move to TCP IP protocol suite. What is TCP IP? TCP means transmission control protocol oblique internet protocol. So, this is associated with OSI model only, because OSI model is having 7 layers, it is having 5 layers. I am going to show you that how these are interconnected to each other. The layers in the TCP IP protocol suite do not exactly match those in the OSI model. The original TCP IP defined having the 4 layers, that is host to network, internet, transport and application layer. However, when TCP IP is compared to the OSI model, we can say that the TCP IP is made of 5 layers, that is physical layer, data link layer, network, transport and application. I am going to show you that what is the mapping of, how the mapping of this will be done between the transmitter and between the OSI model and TCP IP. In case of OSI, there are 7 layers are there, but in case of TCP IP there are 5 layers, namely physical layer, data link layer, network, transport and application. Now, this diagram is basically showing the mapping of 7 layers of OSI with the mapping of 5 layers of the TCP IP protocol. So, I am going to discuss this in detail. This part is known as TCP IP and this part is known as OSI model layers. Okay, so, you can see that there are 7 layers are there, like physical layer, data link layer, network, transport, session, presentation and applications. I have discussed that at every point of time, at every layer, header will be added to each of the layer. Like at the 7th layer, this is the application layer. When the data will move towards the presentation layer, header of the presentation layer will be added. Then when the data will move to the session layer, header of the presentation session layer will be added. At the transport layer, both the header will be added and the data will be divided into different segments, and each segment is having their own header, and the same header has to be used at the receiver side. In case of the network layer, the data will be divided into packets. Then at the data link layer, the frame formation will be done, where the header and the trail bits both are added at the beginning and at the ending of the data respectively. Then at the physical layer, the data will be formed and header will be added, and it will be converted into 1-0 form, and then it will be transmitted through a transmission medium. So, this is about the OSI model. In case of TCP IP, as you can see that the addition of these physical and data link layer of the OSI model, this will map to the protocol defined by the underlying network, that is host to network. This is the first layer of the TCP IP. In another way, you can say that the combination of physical and data link layer will make up a single layer, that is known as host to network layer. Next is the network layer or the internet layer. It will map to a internet protocol. This IP is known as internet protocol. Now, there are different protocols associated with this IP. You can see that this is RARP. RARP is reverse address resolution protocol. This is address resolution protocol, ICMP and IGMP. So, there are basically 4 different protocols associated with internet protocol. This is the second layer of the TCP IP. Next is the third layer of this TCP IP is SCTP, TCP and UDP. What is SCTP? SCTP is nothing, it is the streamline control transmission protocol. TCP is transmission control protocol. UDP is user datagram protocol. Now, these 3 protocols, first thing is associated with the transport layer, means it is definitely or directly related to the transmission of the data. User datagram protocol means whenever 2 users are involved in the communication, the data will be transmitted in the form of datagrams. In case of this TCP IP, that is known as the transmission control protocol. Whatever controlling information, synchronization information has to be added with the transmission purpose or the transport purpose, that has been associated with transmission control protocol. Third one is the SCTP, that is streamline control transmission protocol, that is streaming of the data will take place. Now, next is when the addition of 3 layers at the OSI model is there, like the session, presentation and application, this will make up a application layer only at the TCP side. You can see over here, this is SMTP, the first application, that is known as simple mail transmission protocol. Whenever you want to transmit any mail, any email like in the form of an text information, that is known as the simple mail transmission protocol. Next is the FTP, that is file transmission protocol. Then HTTP is there, this is domain network service, this is SNMP, this is telnet, tele network. So, these are the different applications, and you can see that there are n number of applications associated with the application layer, and the addition of 3 layers, that is session, presentation, application, the work of these 3 layers will be mapped to a single layer of the application layer of the TCP IP. Now, you can see that how these 7 layers are mapped to the TCP IP, means how the number of layers or the number of steps, number of layered task will be reduced from the OSI model to the TCP model. From 7 layers we have moved to 5 layers only, or you can see in this diagram there are 4 layers only. So, this is the case for TCP IP. In case of this application layer, whatever application, like I have taken an example of taking a printout from the device B, like device B is nothing, it is a printer, and device A that is a transmitter wants to take the printout from the receiver. So, in that case another application will be used. So, this is the case for telnet, this is the case for tele network. Whenever I want to transmit any mail, then it will be SMTP. File transfer protocol, the file may be in the form of video with their own extension, the file may be in the form of image, it can be in the form of text. So, that is an example of FTP. Next is hypertext transmission protocol, HTTP. HTTP you are familiar with. Whenever you are open any kind of website, then HTTP is used. Then DNS, domain network service, SNMP, telnet. So, these are the different applications that we have seen over here. So, in this slide we have seen OSI and TCP IP model. Let me just summarize once again, so that because these layers are very confusing, you maybe you have not understood about how the headers has to be added. So, let me just consider this once again. This is the layered architecture. You all have understood that device A and device B all both are connected, and there are two intermediate nodes are there. These may be a router, this may be a gateway, this may be a hub. Whatever information you want to transmit, it is done from 7 layers. This will move towards down at the transmitter side, and at the receiver side it has to be moved up, and there will be a peer to peer protocol will be set up between the 4th layer, 5th layer, 6th layer and 7th layer. So, these points have to be kept in mind, and also there will be an interface that has to be set up between the 2 layers, any 2 layer, maybe a first 2 layer, 3 2 layer, 4 3, 5 4, 6 5 and 7 6. So, this is the layered architecture. Then we have seen different layers in detail, like what I was talking about, that from the device A, this is device B, this is a transmitter, this is the receiver side. At the first layer, at the device B, this is the last layer. So, the data has to be in the form of 1 and 0, and this is the header form. You can see that 110 I have used for the synchronization purpose, and same 110 has been used at the receiver side for maintaining the synchronization, so that the data has to be transmitted and received at the same point of time, there will be no delay. So, that is an example of the physical layer. This is the view of how the information will be transmitted or received at the physical layer. This is the transmission medium, this is wired, it may be a wireless. Now, next is the transport layer. Transport layer, you have seen that the data will be divided into different segments, and each segment is having their own header, which is header 4th, because it is associated with the 4th layer. So, header 4 are there associated with each of the segment, and same operation has to be used at the receiver side. At the transport layer, when the data is divided into different segments, at the receiver side these segments will be received, and these are to be added together to be transmitted at the session layer. In the session layer, what it is done, the synchronization data has been inserted, maybe 1 bit or 2 bit, whatever synchronization bits you want to transmit, number of transmission bits, these are added at the session layer, and same has to be used at the receiver side. Next is the data link layer. In the data link layer, we have to use the frame. Frame is made up of message, header, and it is made up of trail bits. So, these three will make up a frame. At the transport layer, the packet will be formed where the data it is being headed by the header. This is at the 3rd layer. So, this is how the network layer operation will be performed. Next is the presentation layer. In the presentation layer, the data is headed with the header, that is the 6th layer header, and then at the application layer, there are different applications associated with the work that you want to perform from the device B. So, that is the case for application layer. Next, we have discussed about the TCP IP, how the 7 layers of the OSI model are mapped to 4 layers of or 5 layers of the TCP IP, that we have seen in this diagram only, which I have discussed already. 7 layers, you can see that the first 2 layers are mapped to this protocols defined. Then this is the network layer is mapped to internet protocol layer, which are having these different 4 protocols: reverse resolution, address resolution protocol, ICMP, IGMP. Transport layer is having 3 protocols, that is transmission control protocol, user datagram protocol and SCTP. And then application layer, these are having 3 different types of application, whatever you want to perform. So, in this lecture we have discussed about different layers, how the data will be transmitted from this OSI model to the TCP IP model, how this mapping will be done. So, thank you for this lecture.